All right. Well, good afternoon, good evening, and good morning to people that are attending this session. So this is the second of our four planned panel sessions this term to learn a little bit about each of the disciplines that are available for you for applying for second year. So for you, it's the experience in this first term is to we hope that you get a chance to learn as much as you can about the options that are available. A number of these options might be, the names might be familiar with you. Some of them won't be. And to us, this is a great opportunity to learn more about what applied science, what engineering is like at UBC as well. And so for the panel today, we have four of the disciplines and representatives from each to share a little bit about their programs, about where their students end up for co-ops and after they graduate, the kind of experiences that they will go through as well. And maybe some of the similarities and differences that their program has relative to some of the other programs at UBC as well. So amongst our four programs today, for civil engineering, we have Dr. Pierre Berube. For environmental engineering, there's Dr. Majid Mohseni. For geological engineering, it's Dr. Eric Eberhardt. And for mining engineering, it's Davide Elmo representing as well. So amongst those four, what we have are a set of questions that we'll rotate through. There's a kind of a suggested amount of time for each of the panelists to respond to them. We'll rotate up amongst the different panelists as we go through the questions. And then after that, we'll open up the floor to open questions from people here that will want to know about the programs. Make use of the Q&A feature to ask any questions that you're interested in finding out about the programs. And you can upvote things that you see that are interesting for you that you too want to know about. And we'll try to get to those after we do I guess the formal round of questions as well. Okay. So to get started, the first question that's open to the panel is to kind of introduce your discipline. And so the question is to describe what the discipline of your engineering program is about, including the main industries where your graduates work, and maybe the types of jobs that they get involved with as well. So we've got maybe 2 minutes per program allotted. So we'll go in the order that I introduced you. Dr. Berube, maybe the floor is yours.
Thanks. Civil engineering is a very old, I believe it's actually the oldest field of engineering that exists. It's a very broad field of engineering that exists. And in preparation for this, I looked online for definition of civil engineering, and I actually didn't like any of them. So when I came to the conclusion is that civil engineers, we provide basically the infrastructure that shelters people. We provide the networks that allow people to get from A to B. We provide the water that allows us to function. And essentially, civil engineers provide what society needs to function and flourish. And that's a very, very broad definition. But what I found more interesting about the definition as I continue to look into it and think about it is that what really distinguishes civil engineering from other fields of engineering is our client. In civil engineering, our client tends to be society. So we provide whatever society needs, and that really impacts how the profession has evolved. Usually the needs of society are big, so civil engineering projects are big. So that means they're multidisciplinary, they're collaborative. Also, civil engineering projects, because they address the needs of society and the needs of society are constantly evolving, it's an evolving profession. Historically, civil engineers, you might have think of, they build structures, but now civil engineers are responsible for smart cities, sensing in cities, cities that adapt to our use. And also because the needs of society don't really oscillate over time, civil engineers tend to be, or civil engineering as a profession tends to be a little more stable than other engineering professions in terms of how the profession does in economic downturns or unforeseen events like the current pandemic, where many other fields of engineering tend to be impacted by the ups and downs of society. Civil engineers, it's pretty consistent. In fact, it's almost the opposite. When things go slower, the government tends to invest in civil engineering projects that serve society. So in defining what civil engineers do, I think what I came to the conclusion in looking into this, thinking back what I've worked on and what our students work on, it's essentially it's projects and services that serve society.
Thank you for the response. For environmental engineering, Dr. Mohseni.
Thank you. Well, environmental engineering is a discipline that came out of multiple disciplines that are out there, from civil engineering, from chemical and biological engineering, geological engineering. We have representations from those disciplines in here as well. But the aim of environmental engineering is really to work towards ensuring the well-being of the society and global ecosystem that we depend on, our society depend on. I mean, there is no secret, the challenges of environmental issues that we are facing with, and those are of global magnitude and also local aspects or local magnitude as well. And so what are the issues are out there that environmental engineers trying to address? Whether it's a safe and secure drinking water supplies, liquid waste management, contaminated soil and solid waste management, clean energy. I mean, we hear about the impacts of climate change. Environmental engineers contribute to clean and carbon neutral energy systems, resource extracting resources from various sources. So the building blocks of environmental engineering, as I mentioned, is really very much similar to other disciplines, rely on mathematics, chemistry, biology, to some extent physics as well. So the graduates of our program find their jobs in a variety of areas, industries, government agencies, even NGOs. Just to give examples of those, municipalities such as Metro Vancouver or Capital Regional Districts in Victoria are employers of our graduates. Many consulting engineers, whether local or multinational consulting engineers with many, many employees, are also employers as well.
Okay, great. Thank you very much for the response. Dr. Eberhardt, for geological engineering.
So geological engineering is an interdisciplinary profession. It's focused on solving engineering problems that require an understanding of the natural Earth environment. And so if you sort of look at the different programs that are represented here today as a Venn diagram, where they probably come together and overlap is what we call geological engineering. In some countries, it's a specialization or closely related to civil engineering, and 25% of our program is our courses in civil engineering. But I think geological engineering as its own program started 100 years ago here at UBC. It's now international, but it actually started here at UBC 100 years ago, and it was the focus of what was happening in a new province, building large dams for power, building new mines in terms of the resource industry, and all these involved interacting with that natural Earth environment. And so what geological engineering is it brings together that engineering mechanics, it brings together that knowledge of geology, the natural environment, and it provides a versatile set of skills required for the design of large infrastructure projects and the protection of the natural environment. And so where a lot of the jobs are then is because of this history in Vancouver. Vancouver is a key international center for consulting services related to geotechnical infrastructure projects, related to mining projects, related to environmental protection. And so I'd say 50 to 75% of our graduates go on to work for consulting companies, whereas the other 25% maybe end up with working with large operating companies like BC Hydro or Teck Mining or any of the large operating companies. Yeah.
Yep. Thank you for the response. Dr. Emo, on behalf of mining engineering.
Thanks, John. So we tend to say like the mining is basically part of a lifestyle. I mean, if we just look around you, just look at the laptop that you use, anything that surrounds you basically relates to mining, basically relates to resources that we need to extract to basically sustain our technology, our society. So it's just more than rocks, minerals. That's why people tend to look at mining as a rocks, mineral, just basically the product that we extract, but it's more than that. So there's lots of opportunities basically in mining industry, not just to work in relation to the extraction actually of the resources, but to work in relation to the environment, and to work in relation to the technical aspects, so basically the construction of the mines, to work in relation to the social aspects, environmental aspects, and financial aspects of the mines. I mean, because of the investments related necessary to build these large, basically, infrastructures. I mean, a mine is not just a hole in the ground. You have basically multidisciplinary, basically, activity that goes with it. Civil engineering, geological engineering. So it comes together, basically, lots of connection with other disciplines. Our graduates tend to work, the majority, of course, for mining companies, but it could be mining companies in dealing with the metal or basically or in industrial minerals, but also construction minerals, like even just extraction of the material to make cement, to build our buildings. Energy as another big one, like not just the oil, I mean, but mostly just the energy sector, just with the new even renewable energies. They tend to work for consulting companies, but also for the suppliers, so the people that actually build the machines that are required to extract the resources, extract the minerals. So you may have the mechanical engineer designing the machine, but that's design up to specification that are provided by the mining engineer. And there's lots of opportunity to travel in mining engineering just because of the location of the mines. So you may have to even fly in, fly out type of situation where you base maybe in Vancouver, but you work 2 weeks of your time, 2 weeks on, 2 weeks off, and maybe in Northwest Territories. So you have to fly in and fly out. You spend the 2 weeks working, 2 weeks basically kind of resting after. So there's lots of travel opportunities if you like travel. And one thing also that we like to mention is that it's actually for a new graduate student, one of the most, the better paid basically discipline in relation to others, just because of the challenges of working maybe remotely, but also because of the higher basically fees that are involved with the mining.
Well, thank you very much for the response, and thank you all for that. The next round of questions is actually focused on sort of getting in touch with other programs as well. So the question prompt is, which other engineering disciplines do you think your program shares the most in common with, and some of the reasons why? So here we'll start with Dr. Mohseni with environmental engineering.
Thanks. As I mentioned earlier, really the environmental engineering is well connected to other disciplines. It's a multidisciplinary program. The founding departments that formed our new environmental engineering programs are civil and chemical and biological engineering. So we do have representations from civil engineering, so I'm not going to mention quite a lot about this, but certainly geological engineering is another discipline that is very much connected. So in fact, our students take courses from all three programs: geological engineering, civil engineering, and chemical and biological engineering. What it means is that we take courses from, or fundamental courses related to civil engineering and chemical and biological engineering, and also some applied courses from those programs as well. Just to give you examples, mass and energy balances, thermodynamics, transport phenomena. Those are courses that are very much fundamental courses in chemical and biological engineering program, but those are also fundamental to environmental engineering program, because to apply the skill sets to be able to solve environmental or pressing environmental issues, such as clean water, clean energy, or solid waste management, we do need those fundamental knowledge.
Okay. All right. Thank you for that response. For geological engineering, Dr. Eberhard.
No, I mentioned that, we have a significant number of our courses are in civil engineering. So we obviously have a lot of overlap with civil engineering, especially with the geotechnical specialization in civil engineering. So, the materials that we work with are of course, soil, rock, and water. From a soil perspective, a lot of those courses and a lot of our collaborations are with civil engineering. On the rock side, a lot of it is with mining. And a lot of the courses our students take and collaborations, in addition to the geological engineering courses we talk, and as Majid pointed out, on the water side, the environmental side, a lot of those courses are in-house, and some of the environmental engineering students take our courses. But of course, there are also environmental courses in civil engineering that our students take. And so there's a lot of movement, both in terms of the core program, but also the electives in terms of students sort of picking their streams. So yeah, the overlap is for us is very much with all three of the other programs here. Civil engineering because of large infrastructure projects like building dams, mining because again that's a huge employer, and there's a lot of activity in terms of large mining projects both in BC but internationally. And then both those projects, whether it's infrastructure or mining, we're always looking at the impact that engineering designs have on the natural environment. And so the environmental engineering plays has a lot of overlap with what we do.
Yeah, thank you for that. Dr. Elmo.
Thanks, John. So I would say definitely like we have lots of links with other disciplines. That I can actually give an example myself. I'm a geological engineer working in mining, actually, not like a mining engineer. So you can definitely see that we have lots of connection with geological engineering, as Dr. Hebert explained, because of basically the extraction of rock, basically the excavations involved. We do civil engineering. We have some connections, well, just because some of the structure that needs to be built in associated with the mines are civil engineering structures like earth retaining structures, tailing dams, environmental engineering, because of the importance of considering the environment when you extract the resources. We also have links with chemical engineering because of the processing side that we have. Half of our program is actually mineral processing, so there's lots of links with chemical engineering. And we're developing more links also in terms of the computer engineering side because of the increasing role of automation and machine learning, artificial intelligence in mining, with lots of now mines actually operating autonomous fleets of big oil trucks. So that's becoming more and more important, so kind of links also with the computer engineering.
Yeah, thank you for that overview. Dr. Berube for civil engineering.
Well, if maybe we can step back and look at historically the three, especially the four fields of engineering that are present today. There have always been linked, but they tended to be more siloed than they are today. And as the discussion was made obvious today, these four fields of engineering are extensively linked. 20–30% overlaps are numbers that people have been throwing around. So they're all very closely related. And like Dr. Elmo, I'm a civil engineer, but I consider myself an environmental engineering because I work in an area that's much closer to what Professor Mussini is talking about today, the provision of clean water. In fact, I collaborate more with Professor Mussini than I do with many colleagues in civil engineering here. So there's a lot of overlap, there's a lot of complementary, and increasingly all projects require you to have knowledge of other fields, working knowledge of other fields, and then you choose your specialty in one of the more traditional fields where you have a greater impact and work with others in the other fields.
Yeah, that's a great insight for just how to approach things from your program. The next question prompt is about the research side of things that happens within your programs, within your disciplines. So what are a few examples of current research areas in your discipline? And so we'll rotate again. So Dr. Eberhardt for geological engineering.
So I'd say at least at UBC we have three key research focus areas. One is natural hazards. So we live in a mountainous environment. So there's a lot of research in our program related to landslide hazards, especially, but also earthquake hazards and collaborations with civil engineering on looking at sort of the ground structure interactions. A lot of my research, my personal research, is in the mining industry, and it's as we go deeper in the ground, it comes to the question of how deep can we build these mines in terms of an underground environment or in terms of a large surface mine? How deep can we go, and how does the rock behavior change as we go deeper? So we're looking at trying to reduce accidents or improve safety. And the third area is on the natural environment side is looking at the interactions between either contaminants on surface, maybe it's mine waste, maybe it's oil spills, looking at what that does in terms of interacting in the near surface with the groundwater, and how we can better protect the water resources in the ground against those type of spills and contaminants.
Oh, very good. Rotating next, Dr. Elmo for mining.
Thanks, John. So as Dr. Hebert said, basically, we also do research in basically importance of deep mining, basically extracting resource at depth. And actually, we collaborate a lot with Professor Hebert. I mean, personally, like collaborate a lot with him on this in this field. We also do research in automation, basically autonomous, basically all trucks and drill rigs. We look at an energy system to try to basically reduce the amount of energy required to cool basically the air, to ventilate the mine, or just cool the air because of the temperatures that you may actually expose to when you mine deep underground. We look at also urban mining, so basically try to recycle resources. That's another big areas of research in our department, just because it doesn't mean that we have to only exploit existing resources like stuff that is in the ground, but we try to make the best also of what is already been extracted. So try to find ways to recycle as much as we can, particularly rare earth minerals and copper and other minerals that are used now in electrical vehicles. And this is actually new, at least for me. I'm doing also research in machine learning, but not only in the coding itself, but actually in the role of what I call behavioral rock engineering. So basically, how basically the human mind and the cognitive bias plays in try to teach some type of disciplines to machines. That's actually kind of a new area of research that have been developed in the last 1 year to 2 years.
Oh, that's great coverage for the kind of research that happens in the department. That's great. Dr. Burley for civil engineering.
As I mentioned, civil engineering is quite broad, but pretty much most of the activities can be classified into one of 7 areas. And within those areas, some of the examples is, for example, in environmental engineering, the ongoing research is trying to convert used water treatment plants or wastewater. When we flush it down the toilet, instead of being a waste, they can actually be producing energy. So converting wastewater treatment to actually electrical power plants. Some of the work that colleagues are doing in transportation is predicting when collisions would happen, so that if you know when and where or possibly they could happen, you can prevent them. In terms of materials, some of my colleagues are working on concrete that repairs itself. So if you can imagine that you could have an entire city with roads and buildings of almost self-healing concrete. And there's lots of research in construction and project management, especially because the projects are getting bigger and bigger. And a field of evolving research is how to virtually pre-build these systems or this infrastructure, and essentially walk through it virtually to make sure that the functions of the building or of the structure will be met before it's built. So those are just some of the examples of the different fields of civil engineering.
Yeah. Again, just such a great range of opportunities within the department that way. Dr. Mohseni for research in environmental.
Well, there are many research topics or areas that environmental engineers engage in research in those areas. I listed some of those earlier on, the broader area, but I'm just going to list a few of examples of those research areas that we do. I know my colleagues do at UBC here as well. So, for example, capturing carbon dioxide from industrial emissions and turning it into value-added products. So this is something that is very much important and in mind of everyone in the society because it's linked to climate change. So we are trying to address climate change. Dr. Brubey mentioned in terms of clean water, we have been working together over a decade trying to improve the quality of drinking water for our fellow citizens who live in remote areas and among indigenous communities as well. Another area that is very much related to these days is coronavirus. Disinfection of indoor air and confined airspaces such as airplane cabins or SkyTrain cars using ultraviolet irradiations, or using various techniques to monitor wastewater in order to detect possibility of coronavirus infection in a community as an early detection methods as well. So these are some examples of the research that we and my colleagues do in general at UBC.
Okay. No, that's great. Thank you for that response as well. So now thinking a little bit more about some of the student experiences going through different programs. The next question prompt is, what are the key features of your respective programs at UBC, including opportunities students have to gain experience or tailor their degrees in some way? So you may have picked up on my pattern. So Dr. Elmo for mining engineering.
Thanks, John, again. So in a mining engineering program, actually, as I said, it's mining engineering and mineral processing. So we do basically teach, and study, students learn about mining, basically extraction of the resources, but also the processing of the resources, because you have the rock and the minerals that eventually has to be transformed in something useful for the industry. So we also have all the chemical and engineering side of the extraction side and the processing side. So we have you start with the second year where you cover still kind of broader introduction to maybe soil mechanics, rock mechanics, what is mining, electrical, mathematical components. And then in third year, you go deeper into key topics about mining and mineral processing. And then in fourth year, you really go basically advance those topics. So you can start to basically specialize in one of the two. You may be able to basically do kind of more broader, like a little bit of mining, a little bit of processing, but also we have kind of internal streams where you can just focus on the processing or focus on the mining side, depending on what basically you want to do eventually in your career, depending also what kind of co-op experience you got. We have lots of students that do co-op, and we really encourage people to do the co-op basically working in between second and third year, between third year and fourth year. And some students actually take maybe 4 months, 8 months. Some students even took one entire year working at the mine sites because the employer asked for that. And so basically they push the degree forward by 1 year, but that's actually positive in the sense they get very good experience, and the experience eventually pays off because eventually they actually get a job with that employer. And I also like to mention that we are in a phase of changing some of the courses. Mining industries changed a lot in the last 10, 20 years. And there are courses that maybe they're not that relevant anymore. So we try to update those. It's basically slowly changing. And the idea is to make it more a reflection of what the mining industry needs. We have an industrial advisory committee that basically is linked with our department and can advise on what the mining industry needs and try to basically, based on that, kind of steer our program to basically match what basically the mining industry or the industry in general basically needs. And we definitely try to put more emphasis now on the social and the environmental aspect. We have a course that is actually offered to everyone in applied science now as a humanity course, which is Mine and Indigenous People, which is basically looks at the role between the mining industry and indigenous people, and there's lots of participation actually by First Nation on this course.
Yeah, thank you for the overview. These sound like really exciting changes for your program coming up. For civil engineering, Dr. Berube.
So for our program, the second and third year, these students get exposed to the different fields of engineering. And in fourth year, they get the opportunity to select or specialize in one area that's of greatest interest to them, and then apply what they've learned in their coursework to a large capstone project that, like civil engineering projects, would have people that have decided to focus in different areas of civil engineering. So we work in a collaborative, multidisciplinary environment. And as a department, we're one of the larger departments. There's approximately 550 or so undergraduate students from almost 200 different countries. There's approximately 25% of the student body are women, and we're happy to see that consistently increase from year to year. And our students are very engaged. They're engaged in different clubs. For example, the traditional concrete canoe and concrete toboggan are very popular clubs that allow the students to socialize, but also travel, meet students from other universities and compete. But there's also more multidisciplinary teams that involve different areas of civil engineering. For example, the rocket team seems to be very popular with our students. And then there's also international opportunities like Engineers Without Borders. So students really take the opportunity to extend their learning beyond the classroom. And our students and our research is really what drives our everyday excitement of coming to work and learning from each other.
Yeah, no, that sounds like a great setup in the program. That's great. Thank you. Dr. Mohseni for environmental engineering.
Well, environmental engineering is, as a program, is relatively new. We had our first cohort of students to our second year this year. So what it means is that we got the best of the programs or various programs that UBC has or applied science has in terms of relevance to environmental engineering. But also we added some special courses and new courses, and these are design-based courses. So what really makes it stand out compared to many other environmental engineering programs across the globe is that we do have a lot of design components. So starting from second year, our students engage and participate in design programs that allows them to work on real projects, mostly relevant to the communities, but also relevant to industries as well. So as part of this, they get a lot of opportunities to engage with other stakeholders beyond university and really get to learn from them as well. Another aspect of environmental engineering program is the fact that UBC as an institution is very much committed to making a positive impact to the society and the community by being an example of good environmental steward and really promote sustainability. We do have sustainability initiative program across the campus. And we have many other units and departments that really have sustainability and environment as the core component within their activities. So our students who are part of the program can really link with those groups and units and learn from the expertise that is available across the campus. Dr. Bourbe mentioned Engineers Without Borders. This is a student initiative that really is applied science-wide, and our environmental engineering students participate in there. There is also another student initiative program called Engineers for a Sustainable World. That's also something that our students can participate and are able to really, as part of this, work on real projects that are bringing impact to the communities. Yeah. And finally, the co-op program that exists allows the students really to work in local industries that are focusing on the environment. And there are many consulting companies in Lower Mainland that have various focuses. Some of them are focusing on addressing environmental issues in the mining sector, some in municipal sector, some in other sectors of the society as well. So our students, as part of their co-op and of course future job prospects, can work in those industries and gain experience.
Yeah, that very good. Thank you very much for the overview. Dr. Eberhard for geological.
So we have three streams or flavors of geological engineering. We have a geotechnical stream, a environmental stream, and a energy and resources stream. But these are really revolve around technical electives that students choose in their third and fourth year. And really the core of our program is sort of focused on the concept of how do you identify and manage uncertainty in engineering design? And so if you think about engineering activities, maybe working with concrete and steel, these are engineered materials. These are materials we make, and so we have a lot of control. On the geological engineering side, when you're dealing with having to build on or build within the earth, you're dealing then with earth materials that are hidden beneath the surface. And so that introduces a lot of uncertainty and risk into engineering design. And so our program steps through, the fundamentals and how to make observations. And so going out in the field and how do you read the landscape? How do you put numbers to geology in terms of, and how do you recognize potential hazards or potential means by which geology might impact your engineering design, or vice versa, how your engineering design might impact that natural environment. And then we step that into then modern engineering tools in terms of using things like remote sensing, using advanced computing, machine learning, numerical modeling, and how do you then carry out these tools that seem to be very deterministic sometimes, or needing having a need for data certainty. How do you use these engineering tools when actually your problem is very poorly defined, unconstrained, and encountering a lot of uncertainty? And so that's sort of where our program takes students through. And then they have the opportunity, both in terms of through the courses that we teach in the field. We have a small number of field courses, but also through things like co-op opportunities and summer jobs where they go out and work on a large infrastructure project like Site C, or go out and work in a mine in northern or eastern BC. They get to then experience, that sort of uncertainty of looking at something and saying, how do I design for that? And then bringing that back into the classroom in fourth year, where we sort of try to bring that all together before they go off into, graduate and become practicing engineers.
Yeah. No, that's a really interesting perspective on the dealing with uncertainty to this kind of degree. That's really interesting. So the next question prompt is somewhat related to what we talked about, but maybe diving a little more into the feeling of student environment, student community, the kind of interactions that students might expect to have with the program. So what is the student experience in your programs like? Maybe just a few highlights, maybe a minute from each of you on that. So back to Dr. Berube for civil engineering.
Well, as I mentioned, there's a lot of opportunities for students to work together, and realizing how important that is to our student cohort. So one of the distinguishing features of civil engineering is this design studio that we have, where students from different years all come together into this shared space and work on these multidisciplinary projects that prepare them for their careers in engineering. And as was mentioned by the other programs, our students typically then go on to similar, often very similar employers like consulting firms that provide services that are more of the traditional civil engineering, but also within the new fields of engineering, and how closely those are related to mining, geology, geotechnical engineering, and environmental engineering.
Very good. Thanks very much for that. Dr. Moseni for environmental engineering.
Well, somewhat was mentioned that there are student initiatives, such as Engineers for a Sustainable World or Engineers Without Borders. I mean, these are opportunities for students not only within environmental engineering program, but also work together with other students from other programs in a multidisciplinary manner, really to work on issues that are relevant to the society and the community as well. I also mentioned earlier about the design-based courses. I mean, these allow opportunities for students to work together, but also to interact with outside the stakeholders. I mean, all of these provide a much richer learning environment for the students as they go through the program. As part of the program, like many other programs, we do arrange and we do have industry nights, networking events that provide opportunities for the students really to mingle with industry folks, people from outside. Some of them are going to be alumni. All of these are going to be exposing them to what's happening outside. And finally, as part of the new courses that we are providing the opportunities for mentorship, not only from faculty members, but also from outside industry folks who will come to the courses and attend and participate and work with the students and provide mentorship along the way.
Yeah. No. Yeah. Thank you very much. That mentorship aspect can be really valuable getting started in your careers and at university. So next is Dr. Eberhard.
So geological engineering, we're a relatively small program. We cap the program at 40 students that we admit each year. But we have a very engaged and vocal student group in terms of our student club is the GeoRocks. They're one of the more vocal groups on campus, and they do assume a lot of leadership positions. They've served, a punch above their weight in terms of leadership within the EUS, Engineers Without Borders. They're often represented with those leadership groups, and they organize within to be very supporting of the students. So there's a mentorship program where the third and fourth years mentor then the second years who come into our program. So it's a very cohesive group. They've got a really nice club space, and because we have such a large alumni and industry base here in Vancouver, there's a lot of activities as with the other programs. Related to engaging and having activity nights with the alumni, and so it's a very they go our leadership group from our students become leaders in the local community, and they're always coming back and touching base with GeoRocks and with the geological engineering program.
Yeah. Very good. No, it's quite a thing when you can build up a community like that. It's great. And Dr. Elmo for mining engineering.
Thanks, John. So our students basically, I think they take advantage of the fact that we are a relatively small department, so it's easy to connect basically between them, but also connect with the faculty and basically the instructors. Like it's easy to basically talk to everyone once you get to your third year courses or fourth year courses. Mining students, they get very well involved in what we call the mining games, which is kind of sort of Olympics of different mining schools. So we have a team, they set up a team and they compete with other basically mining schools. That means they travel basically to different locations in Canada or North America to compete with other mining school. They also compete in what they call the mining rescue games. So we have a mining rescue basically team. So they train with first aid, several levels. They train in fire basically hazards, so they get actually valuable experience that they can use later in the job site. They also participate in a fourth year basically field trip, and usually it's all over the world. I mean, this year of course is not going to happen because of COVID, but last year they went to Scandinavia, they visited Finland and Sweden, different operations. They visited other places in Europe. They went before to Greece, they went to South Africa, Chile, basically Australia. So they're very active and basically try to organize this field trip. Of course, for this year, it's not going to happen because of the recent travel restrictions, so they may actually be confined in Canada. But as I said, they're also very involved with the industry, with the industry night, and basically try to get really support each other and take advantage of the relatively small numbers that we have in our department.
Well, yeah, thank you for that overview as well. So the last, I guess, question prompt we had, and to wrap it up for this portion, was to complete this sentence. You should consider joining our program because of blank. We'll keep with the same order we had for the last round. So Dr. Berube, you should consider joining civil engineering because, or if.
Well, if you're interested in multiple fields of engineering and you're interested in working in collaborative, multidisciplinary, large projects, if you're interested in a career that's likely to evolve and change over your lifetime, and if you're looking for a career that's quite robust in terms of how it behaves in economic downturns or uncertainty like we currently are right now, and if you want to have an impact on society, I think all of those are traits that engineers that work in civil engineering could say about their careers.
Okay, thank you very much. For environmental engineering, Dr. Mohseni, you should consider joining environmental engineering if...
Well, before I do that, I'd say that as engineers, we are all here to serve the society. So more specifically, if you want to be, if you choose to be environmental engineer, this will be an opportunity for you to improve the health and well-being of the society and the environment. If you're passionate about it, environmental engineering provides you with that opportunity. If you're interested in having the options of working in various sectors, whether industry or government or even NGOs, environmental engineering provides you with that opportunity. Lastly, but not least, you will have the opportunity to have almost a guaranteed job prospects, because environmental engineering is one of the disciplines that has the fewest or lowest unemployment rate, at least based on the surveys that were done in North America.
Yeah. Okay. Thank you for that. Dr. Eberhardt, for geological engineering, you should consider joining geological engineering
if you're a creative problem solver, if you enjoy a mix of working in the office with state-of-the-art computing, but also in the outdoors where a lot of our projects are. And so also if you enjoy travel, because although there's considerable work in the Lower Mainland, most of the consulting companies who work here, they're working on projects around the world. And so, you know, if you're interested then in working on a multidisciplinary team with other professionals on a variety of projects and with a variety of clients, which is common to the consulting industry. And if you're interested in the natural environment and questions of sustainability and minimizing the impacts of engineering projects, that's, I think, geological engineering is something I think you'd find quite enjoyable.
Yeah. Thanks very much for that. And for mining engineering, Dr. Elmo, you should consider joining mining engineering if...
I would say if you care about the world having basically the resources needed to sustain all these new technologies that are coming online. And we know, as I said, the mining industry is going through some significant changes, and you should consider mining if you want to be part of those changes to make sure that mining moves towards more sustainable paths and make sure that mining basically cares more about the environment and society. So we need to change the way mining has been for the last basically 20, 30 years.
Okay. Well, thank you for that as well, and motivation for thinking, and for all of you for thinking about how programs might fit in with the interests that students will have and the passions that they have for how they want to affect the world as well. So thank you for that. Switching over, this is meant to be a bit of time to go over some of the questions that were submitted or have been submitted by students. So I've got the list in front of me. I think some of those questions have been answered by Professor Yeager and Dr. Pete in the background, but I'll scan through and pick off ones that maybe have touch on multiple programs as well. So
maybe, John, if I could just jump in, one quick one there that would touch on everyone is the number of students in each program. So in geological, so I already mentioned 40, but if the other programs could just mention their intake each year.
In environment is 40.
In mining, usually we take between 20 and 30 now.
And in civil engineering, it's approximately 140.
All right. Okay, thank you very much for that. Just so looking through, one question that's been there for a bit, which specialization is the most theoretical? Or maybe you can comment on how much sort of theory there might be in your programs versus how many practical things, the coverage there is. So sort of leave it open for you to
well,
in.
If I can say, John, I mean, in mining, like you definitely have, you need to look at the practical side. I mean, we're dealing with natural materials, so there is lots of practicality in the sense that it's a material that you don't build, you don't basically generate the material, you work with it. So you need to be ready to apply some practical solutions to problems that may come up at the last minute because of maybe a tunnel is not stable or some structure needs some support. But you definitely need some theoretical background, and it's more basically the theoretical background comes from the need for introducing automation or basically new way of analyzing basically data science in analyzing data that we have.
I'd say all engineering programs are applied. You know, it's the nature of our work. And I think most of our programs, I speak for Geo, but you know, we build on fundamentals. So, you know, for us, it's important to, in second year, for our students to build up a fundamentals of how the Earth works and understanding really complex processes that do somewhat seem maybe theoretical in terms of, you know, what can happen in terms of how Earth materials can change over not millions of years, but billions of years. So as soon as you talk about billions, maybe that seems a bit theoretical, but it's very much applied because it's that understanding of the fundamentals of engineering mechanics and how the Earth works that then comes together for application and engineering design.
Yeah, I just want to add on that really in all of the engineering disciplines, including environmental engineering, we use the fundamentals of science and engineering, math, physics, chemistry and biology really to come up with applied solutions. So we do apply some fundamentals, and some of those applications require a little bit more in-depth theoretical analysis, some are less, but nonetheless it's a combination of all of those and utilizing their knowledge bases for applications.
And the nice thing about all the programs is when you get to your upper level third year and into your fourth year, you kind of switch from more fundamental to more applied. So depending on which your interests are, you get to get your feet wet in all of them. If you're interested in the more fundamental aspects of different aspects of natural sciences, or how those are actually implemented into solving a problem. The grouping of the four disciplines here are very similar. And I believe it was Professor Eberhard that mentioned that if you were had Venn diagrams of the different fields that are chosen to talk today, there's an incredible amount of overlap between them, not only in coursework, but how you function as a student and in day-to-day afterwards. And that's really evident when you look at people practicing in the fields. A lot of my colleagues in civil engineer are actually geological engineer. Or chemical engineers or environmental engineers. And I know a lot of people in mining. My father was a geological engineer and worked in mining. So there's definitely a lot of overlap.
Well, that sounds very good. Thank you for comments on from all your programs there. There was a question that jumped up a little bit on the chart. In general, how prevalent is coding within your fields? Maybe that's within your programs as well as in working in your discipline afterwards as well.
Well, in civil engineering, go ahead, Majid.
No, go ahead.
In civil engineering, you're introduced to the languages that you'll need to solve some of the problems and assignments and obtain the training that you'll need as a practicing engineer. But in general, a lot of the numerical methods that are used, once you've gained an understanding of the fundamental of how they're built, you would use computer packages, so commercial packages that you would then use in your capstone projects. Or as part of a practicing engineer afterwards. So in civil engineering, there's not a substantial amount of coding beyond introduction steps.
The same in environmental engineering. Students are introduced to coding and computational techniques, but further beyond graduation and when you go to work, There are certain specific areas that might utilize those codings and computational techniques. Just to give you one example, when we are assessing the transport of contaminants in large lakes or rivers, we may need to apply those computational techniques and codings.
I'd say in geological engineering, it's something that I'm seeing evolving now, and I'm sure some of my colleagues here, because we do similar work, would probably laugh at for us advanced computing was someone wrote a fancy macro in Excel. We use a lot of commercial engineering design software, numerical modeling, commercial software. But what we are seeing changing a lot is around things like data science and machine learning. We've introduced a second-year course in geological engineering that now uses, which is basically Python, Python programming. MATLAB used to also be quite popular, and I think it's when you have problems that are changing, and when you encounter new problems, you can only go so far with commercial software. And so I think we're starting to see, as we encounter new challenges, new needs for programming that certainly are beyond what I've experienced when I was in practice.
Yeah, even in mining, we do quite more coding now. Like even just look at my graduate students, they do lots and lots of 1 hour coding. Something they may learn them themselves, so they learn basically when they were undergrad students. But even in the undergrad level now, we tend to actually add some coding as part of the actual the courses that we teach. So there's definitely more and more coding opportunities, even like in mining, even if we don't really teach the computer science behind those coding.
Thank you for your comments on sort of the evolution of your programs with regard to the tools that get used and what students might expect going through. We are right at the 1 hour mark here. So I think for the sake of maybe people going off to their next item, we might put the stop to this session. Having said that, I think throughout the year you'll have many opportunities to find out more about these 4 programs in particular, but also all the other engineering programs as well. So there are videos through AppSci 100. There are open house events and program fairs for you to learn about them as well. And I think individual departments will also offer up the opportunities for you to learn about what they cover as well. So our advice to you is to absolutely take advantage of these sessions, these times to learn about the programs. And for ones that you may have heard about, even ones you haven't, I mean, it's a great chance for you to learn about all of the things that happen in engineering and specifically here at UBC as well. So on behalf of the students that attended and who are going to watch the video later, I thank all of the members of the panel for taking the time out today to share their thoughts and perspectives about their programs. I appreciate you sharing, and we will archive this forever for students to learn about all of your respective disciplines. So thank you very much for this. It's really great to have you.
But thank you for hosting, John.
Thanks, John.
Thank you.
Yeah. And now I click the button